Example 2, we're given two vectors a and b in component form, and in part A they're asking us to find the magnitude of a minus 2b. So we can't get the magnitude of a minus 2b until we know what a minus 2b is. So part A, we have to get the vector a minus 2b in component form. So we're going to replace a with its component form, so that's 3i minus 2j, and we'll put that in brackets. Copy down our minus and our 2, and then we're going to replace vector b with its component form, so 2i plus j. Now, when a bracket has a coefficient here, just multiply through the bracket by the numerical value. So keep the negative in between the brackets. So we're going to have 3i minus 2j. Keep the minus between the brackets, but multiply this bracket by 2. So I'm going to keep the bracket, but I'm going to multiply everything inside this bracket by 2. So we're going to get 4i, and we're going to get 2 times j is plus 2j. Okay, so now that there's only a sign between the brackets and it's a negative, what we're going to do is we're going to subtract the I components and we're going to subtract the j components. So 3i subtract 4i is just going to give us minus 1i. We've then got minus 2j minus plus 2j, so that's going to become minus 2j minus another 2j, which is going to give us minus 4j. So we've now worked out the I and j components for the vector a minus 2b. And again, we'll put brackets around it. Now we need to get the magnitude or the length of this vector. Now, we can use the formula. So the magnitude So remember, to get the magnitude or the length of a vector using the formula, it's going to be the square root of the I component squared. So the I component is -1, so it's -1 all squared plus the j component all squared. The j component is -4, so it's going to be -4 all squared. So -1 squared is 1, -4 squared is 16, 1 plus 16 is going to give us 17, so it's going to give us the square root of 17. Now, it didn't say to give it exactly. You could then therefore go to your calculator and you could work out the square root of 17. So that's going to give us 4.1231. And then we could round it to 3 significant figures, so our answer would be 4.12 units, and that would be to 3SF. So that would be the length of the vector a minus 2b. So you have to get what a minus 2b is first in component form, and then use the magnitude formula to get its length. Okay, part B then says find the direction of the vector a minus 2b. So we're going to have to sketch it. So part B, we're going to have to sketch, and the vector that we're going to have to sketch is minus I minus 4j. This is the component form for the vector a minus 2b. So sketch minus I minus 4j. Okay, so we're going to draw our I and j axes. Remember, j axis is the vertical, I-axis is the horizontal. And then put our origin there. Okay, so when we're finding the direction of a vector, using a sketch, always put the tail of the axis at the origin. Just makes it much easier. So we need to then plot the position of the nose. So remember to do that. The I component is -1, so it tells us we move 1 unit to the left. So say roughly somewhere there. That's going to be where -1 is, roughly. And then the J component is -4, so that tells us we have to move 4 units down. And that's going to be the position of the nose, level with -4 on the J-axis. So we're then going to join the nose and the tail together. And remember, the arrow always points at the nose. We're then going to form a right-angled triangle using the horizontal axis and the vector itself as 2 of the 3 sides. So I'm going to rule a vertical line up to the horizontal axis. What we now need to do is work out the horizontal distance between the nose and the tail. So the horizontal distance is just 1. Remember, you ignore negatives when you're working out distances. And the vertical distance between the nose and the tail is just 4 units. Again, you ignore the negative when we're just talking about distances. And then now we're in a position to get the direction. So the direction, remember, is the angle theta, and it's always between the horizontal axis and the vector, and it's an acute angle, so it has to be this little angle in here. So the direction theta we're going to use right angle trigonometry. So there's our angle theta. We know the opposite, we know the adjacent, so we're going to use tan. So tan theta is opposite over adjacent. And then sub in the values. So tan theta is equal to 4 over 1. And then we're going to take the inverse tan. So theta equals inverse tan of 4 over 1, or just 4. Again, just make sure we're in degree mode. So shift tan 4, and that's going to give us 75.963. So to 3SF, that's going to be 76.0 degrees. And again, please be careful when you're working out the direction. It's not just the value of the angle, you have to describe the position of the angle. So the final answer is direction is 76.0 degrees, and you'll notice that the angle here is below the negative x-axis. So below the negative x-axis, or horizontal axis, or I-axis. Okay, and that's it.